We are What Are We Doing? Our project focus on making everyday chores easier. Our problem statement is that people spend too much time on things like laundry, trash, plant care, and security. We designed a solution for everyone who needs extra help. Issues faced while smart home tech is advanced rapidly, most systems will require human oversight and feel incomplete. Laundry robots are either non-existent or stuck in prototype. Security systems are easily disrupted, and plant care devices often have too complicated or expensive for everyday use. Our solution aims to provide robots to ease the burden on these tasks by integrating a laundry robot, security robot, trash robot, and plant care robot in a cohesive system.
This is CycleMate. It essentially is a robot that detects when the hamper is full and then brings the clothes over to the washer to load them. It has a force sensor to detect the weight of the clothes, and then it has an ultrasonic distance sensor in the front to detect how far it is from the washer, and an ultrasonic distance sensor on the claw to detect how far it is from the clothes. This is my circuit. I have the um, force sensor, the two motors for the claw and the arm, and then two ultrasonic distance sensors, and the two DC motors for the wheels. And then this is my algorithm for the robot.
All right, so for surveillance, he's pretty simple. He features a basic design. He has a camera, two wheels, and a front sensor and a battery pack. For my circuit, the circuit features just two motors, one for each wheel, a sensor just to detect any object in front in case it needs to go off track, and then a motor for the camera to rotate 360 degrees.
So rooting for you, there's a plant water robot. It has one ultrasonic sensor, two motor for the wheels, and servo motor for the arms, one ultrasonic sensor, some of the plants, everything start.
Okay, here we have the dumpster demolisher. This robot basically has two sensors, gas sensor and a weight sensor that tell it when it's time to go and take out the trash and then return to home base. And the circuit here you can look at shows all of that. And then the flow diagram shows that as well. Okay, here we have our collaboration scene. We have our trash robot here. And when it sensors trigger, it'll go outside to its designated spot. And then it'll return and go to standby. Here we have our surveillance robot. It'll come in, stay in here for about 30 seconds and do a cycle, and then it'll go on to the next room. In our next room here, it's in our laundry room. It'll stay, do its cycle, 30 seconds, and then go over to the next room. Our plant robot rather is here. It'll check the soil and then move across to the rest and then go to standby. And then we have our laundry robot. It'll go over to our washing machine and do its thing.
Okay, so for the value added, most system in the market right now just focus on one robot, whether it's a laundry robot or whether it's a plant water robot. But our system combine all of those, and user can just do it one time and don't have to worry about doing one thing after another. And that's the value we add in the market.
To conclude, this project was really a learning experience. We figured out how to turn ideas into something that works, how to simplify when things got complicated, and how to adjust when things didn't go as planned. If we had more time, we would have improved a few areas like robot communication and early testing. But in the end, we built something we're proud of. It works, it's useful, and it solves a problem that almost every household can relate to.
So this slide shows all of the references we used throughout the course of this project. And then you can also see them in our document file as well.